Hey guys, so in this video we're going to talk about some values of density you should know as well as specific gravity. Let's check it out. Alright, so you should know certain values and units for density. So you should know that fresh water is 1,000 kilograms per cubic meter. What this means is that if you have a cubic meter of water, right, so you fill it out with water, that's going to have a mass of 1,000 kilograms, which is over 2,000 pounds. Okay, so pretty heavy stuff. So 1,000 kilograms for every cubic meter. And you can also rewrite this as 1 kilogram per liter. That means that every liter of water has a mass of 1 kilogram, or 1 gram per cubic centimeter. That means that 1 cubic centimeter, tiny little amount of water, is 1 gram of water. Cool. So if you remember these, you get two benefits. One, you know the numbers for water, but you also can use this as a way to convert stuff. So for example, if you know that 1,000 kilograms per cubic meter is 1 kilogram per liter, and then I give you 1.2 kilograms per liter, you can immediately convert that and say, well, if 1 here is 1,000 here, then 1.2 of this must be 1,200 of the other. Okay? So this allows you to make some quick conversions by remembering what the ratios are. Now you have fresh water and you have salt water, and this is pretty straightforward, but just in case I have here, anytime the question refers to a lake, a river, or house water, meaning water coming out of a faucet or whatever, it's going to be fresh water. And fresh water is the default water. If you're not sure if it's fresh or salt, it is fresh, okay? And it's 1,000. It's the easiest number out of all of these to remember. Salt water is water, you put some salt in it, and it's water from the ocean, right? Seawater. One way to remember this is, imagine if you have water and you pour some salt on it. Now it is denser, therefore it's a little heavier. That's why it's 1030, okay? Just a little bit heavier. Whole blood is when you have plasma and all the other crap that's in your blood, and that's going to be 1060. Air is 1.2. Now this is not a typo or some weird mistake. Air is in fact 800 times. This is 1,000, this is 1.2, this is about 800 times lighter than water, and that makes sense, right? Air is much lighter than water. If you have a huge box with a bunch of water, that's going to be very heavy. If you have a huge box, let's say a cardboard box, and it's got a bunch of air in it, it's not going to be very heavy. It's also why when you look at the horizon, you see water at the bottom, right? If you're looking out of the ocean, and air at the top, because air is lighter, so it is on top. It's pretty silly, but that's how it is. Cool. You should know that oil and wood are usually going to be slightly lighter than water. A lot of the measurements for oil and wood end up being about 800 kilograms per cubic meter instead of 1,000, so it's a little bit lighter. Those are pretty popular in fluid problems. And the last thing I want to talk about before we do an example is I want to give you an idea of what these measurements are. So you could have a volume as something like centimeters cube, or cubic centimeters or cubic meters, which are lengths, right? But then it's cubed, so it's a volume. Or you can have it in terms of liters or milliliters, which are more readily identified as being volume. And I want to give you a sense of what these things are. So a cubic centimeter, a centimeter is like tiny like this, right? It's less than half an inch. So a cubic centimeter is a tiny little cube, and that's 1 milliliter of water, right? So it's this guy right here, okay? This is 1 cubic centimeter, or 1 milliliter of water. Now, this is what 1 milliliter of water looks like. It's a tiny amount of water. 2 liters of water is your big water bottles, right? And this is what 1 cubic meter looks like. So here's a dude, this guy, the average person is probably, I don't know, 1.8 meters, right? So you would have a box, a 1 cubic meter box would be about halfway up to where you are, and it would be this just big box here, and this would have 1,000 liters of water or whatever, right? So the idea here, one point that I want to make is that 1 cubic meter is gigantically bigger than the cubic centimeter. It's actually 1,000,000 times bigger. Cool. All right, let's do a problem here. Quick example. How much does 500 milliliters, that's a volume, so volume equals 500 milliliters of a 2.2 grams per cubic centimeter. So what is this? Well, this is a mass, and this is a volume. Mass over volume is our density. So the density, it didn't say density, you have to figure out by the units there. It's 2.2 grams per cubic centimeter. And I want to know how much does that liquid weigh. In other words, what is the weight of that liquid, which is mass times gravity. Now, we know gravity. We're going to use 10 here just to make life easier. We know gravity. So really, this question is asking us for mass. If I can find the mass, I will find the weight. How do I find mass? Well, if I have V in rho density and I want mass, I can just use the density equation. Density is mass over volume. Therefore, mass is rho V, and rho is 2.2 grams per cubic centimeter. Remember to always write it in the bottom so it's easier to see, times the volume, which is 500 milliliters. Okay, so there's all kinds of problems here with the units that we're going to have to try to fix. This here is a volume, this here is units of volume as well, but they're not necessarily compatible with each other, or at least they're not the same exact thing, right? Milliliters and cubic centimeters. So can we convert one into the other? And if you remember this piece here, if you remember that 1 cubic centimeter is in fact 1 milliliter, then you know that these two are equivalent. They're not the same, but they're equivalent, so they can be canceled. And then you're left with 2 times 500, 2 times 500, which is 2.2, so it's 1100 grams. But we cannot leave this in grams. We have to turn it into kilograms. So this is just going to be divided by 1,000. So it's going to be 1.1 kilograms. Just some quick dimension analysis there, or really just conversion using the metric system, right? So 1.1 kilograms. Are we done? Not really. That's the mass, so we can find a weight. Weight is mass, which is going to be 1.1 kilograms, times gravity, which can be 10 meters per second squared. So this is going to be 11 newtons. 11 newtons. Cool. So that's it for that one. Now let's talk about specific gravity real quick. And some professors will talk about specific gravity, some won't. If you've never heard this, if you've never seen this in class, you could skip it. But specific gravity is just a term that's related to density. It is density relative to water. It's kind of a silly idea, but you should know it if your professor cares about it. So the definition of specific gravity, SG, so the specific gravity of something is the density, rho, of that something divided by the density of fresh water. And by the way, the density of fresh water is 1,000. So I can simply rewrite this and say that specific gravity of something is density of something divided by 1,000. That's it. Just take the density divided by 1,000. So for example, what is the specific gravity of fresh water? Well, specific gravity of fresh water, you have specific gravity of fresh water is the specific gravity, it is the density of fresh water, because this guy here goes on the top, so this matches up with this, right? The specific gravity of X is the density of X, so the specific gravity of fresh water is the specific density of specific water, divided by the definition of the equation is that the bottom is always a fixed number, which is the density of fresh water. So this is kind of silly because it's just 1. Because specific gravity is relative to fresh water, the specific gravity of fresh water is 1 because it's the same. Okay, so what the heck is this used for? Well, if you know that the specific gravity of something is 2, that means that it's because it is twice as dense as fresh water. And you would immediately know, oh, that means that the density is 2,000. If the specific gravity of something is 0.7, it means that it's 70% of water, which is 1,000. So this would mean that the density is 700. Okay, it's a little silly. They could have just left it at density, but there's this other term you should know. Let's do an example here. It says, what is the volume of a wooden cube? So I want to know what is the volume of a wooden cube with a specific gravity of 0.8. So the specific gravity is 0.8. That weighs 16,000 newtons. So if the weight is 16,000 newtons. What is the volume? Okay, so can we do anything here? So where am I going to get the volume from? Well, there's specific gravity, which is related to the idea of density. And weight is related to the idea of mass, right? There's equations that connect these two. So if you have volume, density, and mass, you can put them together on the density equation. Density is mass over volume. Therefore, if I move some things around, volume is mass over density. So if I can find the mass and if I can find the density, I can find the volume. So let's see if we can do that. So first, let's try to find the density. So the specific gravity of something is the density of that something divided by 1,000. So I can just move things around and find that the density of something is the specific gravity, which is 0.8, times 1,000, which will give us 800. It's very similar to what I did up here, right? The 0.7 became 700, the 0.8 becomes 800. So I got the density, so let's see if we can find mass. So weight, remember, is mass times gravity. And if I know the weight, but I want mass, I can just move things around. Mass is weight divided by gravity. So it's 16,000 divided by, we're using 10, so this is 1,600. So now we can plug stuff in. The mass was 800, and the density was 800, and the mass was 1,600. I got that backwards there. The mass is 1,600, and the density is 800. And if you do this, this is simple. I made the numbers easy here. It means that the volume is 2. Now, what are the units? The units are cubic meter. Why? Because we had standard units. This was 1,600 kilograms. Okay, 1,600 kilograms because we're dividing newtons by meters per second square. So we're using standard units, and then you get a standard unit. And here, this was kilograms per cubic meter. Okay. So long story short, whenever you're using standard units, you get standard units. The standard unit for volume is cubic meter, so you get a cubic meter. So the answer here is 2. That's it for this one. Let's keep going.